All right, last two examples here. What makes these guys different is that they have a charge. These are the polyatomic ions that we've dealt with before. Everything else is exactly the same except for the charge. And the charge comes in when we figure out the total valence electrons. So let's start off like we've been doing. N and H. There's only one N, and there's 4 H's because of the formula. You look on your periodic table, nitrogen's in group 15, so it's got 5. 1 times 5 is 15. I'm sorry, 1 times 5 is 5. I was thinking group 15. All right, hydrogen. There's 4 of them. You look on the periodic table, they each have 1 valence. 4 times 1 is 4. If we add them up, we get 9. You might be thinking 9 is an odd number, like evens and odds. It's an odd number. We've done everything in pairs. Every line, every bond represents 2. We've always drawn electrons together in pairs as dots. An odd number is an odd situation. We shouldn't have that. That's where the charge comes in. Now think about it. If you have a positive charge, that means you have more positives than negatives. Well, why do you have more positives than negative? Because you lost an electron. You lost a negative. So this 9 is going to lose an electron. It's going to go down to 8. That's what causes that +1 charge to happen. So now we have 8 electrons. Everything else is the same, except for one little thing at the end. We still pick our center atom. We're going to pick the 1N and surround it by the 4 H's. We're going to think about giving our outer guys an octet. They're all H's. You can't get any simpler than that. They all already have their version of the octet. They all have their 2. The next step is to see if there's any electrons that remain. 2, 4, 6, 8. We started with 8. We used 8. We have 0 remaining. And the nitrogen in the center has its octet. Everybody's done. It's perfect with these 8 electrons. It would have been a mess with 9. But 8 is perfect. That's why NH4, in order to stay together, it has to lose an electron. It has to act like a metal and give it away. Now, the one last thing you got to do, only for polyatomics, is you have to write the charge +1. This is communicating that this molecule will not form unless it loses 1 electron. And you have to put it in brackets, not parentheses, brackets. And that is how you represent a polyatomic ion. All right, next one. We got N and O. There's 1 N and 3 O's. The N has 5 valence electrons. 1 times 5 is 5. The oxygen, there's 3 of them, and oxygen's in group 16, so it's got 6 valence electrons. 3 times 6 is 18. If you add them up, 18 plus the 5, you get 23. Again, it's an odd number. That's not good. So we have to factor in our charge. A -1 means there's 1 more negative electron. So 23 is going to go up to 24 when we factor our charge in. And now that we have an even number, let's take off. Put the N in the center, surrounded by the oxygens, single bonds. Now give the outer guys an octet. Let's give it 6. Give this one 6, plus the 2 in the bond is 8. This one gets 6, plus the 2 in the bond is 8. All right, everybody's got an octet around the outside. Now we have to make decisions. How many remain? So we look at our number that we started with. We had 24. Let's see what we got here. 2, 4, 6, 8. Another 2, 4, 6, 8. Another 2, 4, 6, 8. 3 sets of 8 is 24. 24 minus 24. We have 0 remaining. That's how you know you can't just say, oh, look at that nitrogen. It needs 2. You don't have those 2. You had 0. You can't just put two of them on there. So if you think about our options here, what's the next thing you do? If you realize the center atom is not happy, it doesn't have an octet, well, then you go to the next step. The next step says I put the remaining electrons. We have 0 remaining. So if you can't do that, what do you do now? I had to make a double or triple bond. So let's do that. Eeny, meeny, miny, mo, pick your favorite oxygen. I'll pick this one up here. Cross those off. They're now no longer just around this oxygen. Now they're going to zip back and forth, back and forth, back and forth between the two, and we end up with a double bond on this side. Those electrons are no longer just around the oxygen, so I'm going to get rid of them. The last thing I have to do is communicate that this can't happen unless it gains one more electron. So I put my -1 charge somewhere on the upper right, and then I wrap it in brackets. And now I'm done.